Hello and welcome to my Module 2 video for Math for Teachers 2, and my name is Patricia Montgomery. So to start out today, we are going to look at this figure and we are going to try to figure out the angle or the degree of each of the angles below. So to start out, we can look at this angle 7 that we're missing for this triangle, and we know that a triangle is 180 degrees, so we're just going to add 61 plus 63 and subtract that from 180, and we're going to get 56 degrees. Now, something to note is that line 1 and line 2 are parallel to each other, which means that angles that are like adjacent to each other and stuff are going to be like the same degree because of the way the lines are. So when we find out that 7 is 56 degrees, we can also see that across from that is 12, and 12 will also be 56 degrees. So the next thing we're going to do is I chose to do angle 8 down here because we just did angle 7, and since we know that across that line is 180, we can just subtract that 7 from 180, and we get 124 degrees for angle 8. Another thing, since the parallel lines worked for 7 to 12, they're also going to work for 8 to 11. So we can conclude that 11 is also 124 degrees. Next up, I did angle 6 the exact same way as we did 7 and 8. And 6 is across from 10, so 6 and 10 equal 119 degrees. And so then we got 7, 8, 11, and 12. Then we got 6, and we have that one, and 10. So 9 here, 9's across from the 61 degrees that they gave us, so we know it's 61 degrees. So we talked about how parallel lines meant that across from each other like that, but it also means that where the two lines are, the angle that's in the same position for each of those lines are also going to be the same. So where angle 9 is, angle 4 is in the same spot on the line 1 and line 2, so they're the same degree. So for 4, it's also going to equal 61 degrees. And then back to the original across from each other, 4 to 3 is going to be the 61 degrees. So we could do this a little bit of a different ways to find angle 1, or if we wanted to, we could do the angle 1, angle 4, and then the 63 degrees is equal to 180. Or we could do that angle 4 and the 63 is equal to the angle 5. Whichever way you want to do it and subtract it is fine. But you're going to get angle 5 and angle 1 are 56 degrees. And then angle 2 is across from that 63 that was given, so it's 63. So knowing that those lines are parallel is how we got a lot of those. Otherwise, it's just knowing that the 180 across are inside of a triangle. And so for this next problem, we're actually going to kind of do the exact same thing, but we're going to look at some different shapes and how that works. So originally on the other one, we had a triangle with like big long lines, but now it's all inside of that triangle. So the first thing I did was I just looked at the whole triangle, 3 points as a whole, so that ACB situation. And so they gave us C and B, so we need to find A. So we add C and B and subtract it from 180, and we get 80 degrees for 1. Then we see, like we did on the other one with those parallel lines, that 1 and 3 are in the exact same spot, so 3 is also 80 degrees. Then we're going to go over here to where you see R, and you see the 7 and the 8. Or no, yes. So the 7 and the 8. Because we can look at parallel lines this way like we already did, but you can also look at them up and down or to the sides this way or whichever direction, as long as they don't intersect with each other. And so 1 and 8 are the same. So we can subtract 8, which is, we found 80 degrees from 180, and you get the angle 7 is 100 degrees. Right? Yes? Yes. Is 100 degrees. And so then we also now have 8 and we have 26 in this QRB triangle. And so we can subtract those and we get angle 6 is 74 degrees. Then we're going to go up here, and angle 2 plus angle 3 is equal to 180 degrees. And so for angle 3, we found out that it was the same as 1, so it was 80 degrees. And 180 minus 80 would be 100. So angle 2 is 100 degrees. And then for triangle C, P, and then Q, we know that angle 4, no, not angle 4, we know that angle 3 is equal to 80 degrees. And then we have the 74. So to solve for 4, we'll subtract the other 2 from the 180. And angle 4 ends up being 26 degrees. And you could also go back and you could check your work any way you'd like. And you could do this Q here and make sure that 4, 5, and 6 add up to 180. And make sure that all of those corresponding angles like that do match by the time you do that. And it's a good way to check your work. So this one's a little bit different when it comes to finding the angles, because we're used to like 180 triangles is like the basic way that we normally look at it. So now we're going to get a little crazy with some shapes we don't see as often. So this is a concave polygon, and we're going to figure out how to do find the y to solve for all of these angles. So the formula you use for any polygon of any shape is n minus 2 times 180, which where n is the number of sides. So when you do that, we're going to start out by counting the sides of this polygon, and we get 1, 2, 3, 4, 5, 6, 7, 8. There are 8 sides. Is that right? Yep. And so we're going to plug 8 in for n. So we'll do 8 minus 2, which is 6, times 180, which gives us 1,080 degrees. So within this polygon, there is 1,080 degrees worth of angles. So to solve for y, we are going to add up all these y's inside of here, and then we are going to divide that coefficient by 180 and find out what that y is left with. So when we do that, we get 20 for our y. So now we have to go back and we have to plug that 20 into each of these y's to see what those measurements are. So for 3y, 3 times 20 is 60. And then for 7y, 7 times 2 is 140, or 7 times 20 is 140. And then we have 12 times 20, which is 240 degrees. All right. So our fun next thing here is we are going to look at this cube, and it's DEGH is our cube name here. And inside of it, we want to put a tetrahedron, which is kind of like a pyramid, is pretty much what it is. It's going to have like that square base, but then it's going to have 4 triangular sides. But the trick is we want to make sure that we don't have any of those faces on this facing the same direction. So what we're going to end up doing is we're going to put this in so that it goes from corner to corner and it matches inside of it just like that. And then none of those faces are going to match each other, and it'll be good to go. So then for this other one, we're going to build these diagrams for a tetrahedron and these other 2 that look a lot the same, but they each have like an extra kind of like shape put into them. And basically the difference is that you're going to kind of look at them in a different way. They look like those really cool things that we had when we were kids that you'd look through and you could turn in and they would be like all the different patterns and stuff like that. Is kind of like how it goes. And then you just build them onto different planes with different shapes to make all these cool, bigger shapes. And that is my video. Thank you.